Well, welcome everyone. Nancy Ostin. I'm the director of IEEE at HKN, and it's my pleasure to welcome you all, those who are just joining us now, or those who've been with us all day so far with the HKN experience. And if you're just seeing this session, we're really glad that you're with us. We have a really great 50 minutes planned for you with Textron and Bell Systems, and they're going to talk to us about driving innovation in the defense industry. I'll let William Schmidt, who's the chief engineer at Textron, and Matthew Waller, who's the director of engineering, go ahead and introduce yourselves. But we're excited to have you with us and really looking forward to what you have to share with us today.
Thank you, Nancy. I'm Bill Schmidt. I'm a fellow electrical engineer at Textron Systems. I run a group that does control systems for the Army's drones on the air side, and it's going to soon be renamed Battlefield Connectivity. And I'll be talking about that side of the business and how we innovate, and I'll turn it over to Matt.
Thanks, Bill. My name is Matt Walsh. I'm the Senior Director of Engineering for the Electronic Warfare Division of Textron Systems. We primarily work with modeling and simulation of the electronic battlefield, everything from commercial cell phone signals all the way up through sophisticated integrated air defense radars. So that's our primary focus. And with that, we'll kick off our presentation.
Okay. I'm gonna do a page down. Oh, there's the page. Okay, just to give you an idea where we are in Textron as a whole. Obviously, Textron is a big piece of Textron is Bell. I'm sure you're all aware of the V-22 Osprey. That's the big defense product they have, and a whole host of other helicopters. They're getting in competition for FLRAA and FARA for the U.S. Army, and a big supplier of both commercial and defense products. Also at Textron, probably the biggest piece of Textron is Textron Aviation. That consists of Cessna, Beechcraft, and Hawker. I just read the other day that among general aviation, more than half the general aviation out there in the world is from, or in the U.S., is from Textron. So if you corporate jets, smaller aircraft, that's all. A lot of that is from those three companies. Matt and I are in Textron Systems. Textron Systems has several parts. There's Textron Systems, the traditional core. There's How and How, Lycoming, and ATAC. Textron Systems has domains of air, sea, land, weapons, and a group called ATAP. Those land, sea, air, and weapons areas have a mix of manned and unmanned products that we sell to defense industry, to the military, U.S. and foreign customers. That's probably the biggest piece of the company there. How and How is a company we bought a few years ago that is specializing in unmanned ground vehicles and some manned ground vehicles as well. Very fast, very exciting equipment that can make a big difference. Lycoming has been the manufacturer of engines for a while for aircraft, and ATAC is a training operation that has fighter jets that basically do active training for military pilots. One of the funny things is we probably have like the third or fourth largest fighter air force at ATAC in the entire world. But that group does a lot of work with training pilots for defense. Then you have industrial, which includes E-Z-Go, that's golf carts and other equipment for a lot for the golf industry. Arctic Cat, which makes obviously devices that drive over snow and cold environments. Textron Off-Road, so four-wheel drive vehicles. Cushman. I have a Cushman hauler myself. I just bought the other week. Finally got one of those. It's a lot of help in the backyard. And then Caltex makes very sophisticated fuel tanks for lots of automotive applications. And then there's Textron Financial, which provides financing for a lot of the other areas. Within Textron Systems, hold went too far. Within Textron Systems, there's several different areas we specialize in. I talked about air, land, and sea systems. It's a mix of unmanned and manned assets, weapon systems. They do reentry vehicles. They do weapons. They do unattended sensors. Matt's group is test training and simulation. I'll let him finish and talk about that in a minute. Lycoming is aircraft propulsion. All of our groups have operations and logistics support that we provide worldwide for both our products and other products that we have picked up to take care of for our customers. Autonomy and control systems, battlefield connectivity is primarily my group within the air area. And we do control C2 applications for unmanned systems and situational awareness on the battlefield. And then imagery and data analysis also comes under Matt. So I'll let Matt talk to his two boxes there.
Yeah, so the test training simulation, we focus primarily on electronic warfare in that domain. So this is dealing with radars, communications data links, both training backseaters in jet aircraft to identify, locate, and defeat enemy systems. And then we also do hardware in the loop simulation. So for the manufacturer of the F-35 or different weapon systems, jamming subsystems, we provide the electronic battlefield environment, but in the lab. So it's all essentially a very large scale video game, but we are feeding in extremely realistic data, RF waveforms, navigation data, so that the jet or the weapon system that we're testing can't really tell the difference whether it's, really getting shot at or is it in the lab. And that's the level of fidelity that we bring in our products. We'll talk more about that and how that ties into kind of our innovation kind of approach at Textron Systems. As far as imagery and data analysis, we have a group out of Sterling, Virginia that focuses in on geospatial intelligence data coming from various platforms, both unmanned and manned air breathing vehicles, so aircraft, and then a lot of focus is on space-based platforms. And even this area is rapidly evolving, and we'll talk more about how we keep up with that rapidly evolving kind of ecosystem in the slides that come up.
Okay.
So yeah, innovation. Next slide, Bill.
Okay.
So there's a common dynamic to all of our innovation, and it's not just us. It's here at Textron Systems. It's across any commercial or defense business that you want to look at. There's a common dynamic that underlies all of the innovation, and this image is there to represent kind of the core concept behind it. If you're not a chess player, this is the queen from the chessboard, and I picked out this image to be the red one because of the next slide. So Lewis Carroll, in his famous book Through the Looking Glass, had a character named the Red Queen, and she's famous for saying it takes all the running you can do to keep in the same place. If you want to get somewhere else, you must run at least twice as fast as that. And this dynamic is expressed in every technology business you want to care to look at. So at Textron Systems, we keep up with advances by our commercial colleagues, so other companies that we compete in the same product environment space. And as a defense company, we also are competing with our nations around the world that we're not necessarily friendly with. And you guys can can figure out the list of people that I'm talking about. And essentially what the Red Queen is saying is if you ever stop innovating, you will lose. And you must focus on constantly pushing the boundaries of what is capable, because if you don't, the other guy is, and you will find yourself very quickly trailing behind, and you may not be able to catch up. So that's kind of the motif for a lot of what we're going to talk about today. Next slide.
Okay, the first thing, several slides I'm going to talk about is the Common Unmanned Surface Vehicle. This is the Navy, U.S. Navy's very first unmanned minesweeper. We were under development or working on this for multiple years, and then all of a sudden it came to be that we won it. It is a platform that can be used for other uses other than minesweeping, but the red thing you see on the back of it is a device that goes underwater and is there to detect mines and to create a signature that may be able to set them off. So this is a great way to keep the soldier out of harm's way, to do a job that was dangerous and dirty and difficult without somebody there that's going to get harmed. And it's something you can scale and have performance with an unmanned asset that you couldn't get with a bunch of manned assets. The same performance from every one of them all the time, covering an area. And then you can refit the boat to go do something else. We have had these vehicles, we've done some testing in which there have been Hellfire missile launches from them and machine guns and successful and big product for us. It has a lot of autonomy in it. And we talk about the innovation. There's some innovation that began with unmanned air innovation on a product we called on the move command and control. And we've been able to take that product and inject it into this along with some other AI and ML that we have from some of our partners into building a vehicle that has autonomy, that allows it to use its sensors to do collision avoidance, to avoid buoys and other ships, and to carry out its mission, and to give it choices about which way to go in order to meet its mission. So it's also very, very robust and has a lot of power, so it can have a lot of payloads and sensors that can be integrated with it. And what kind of skill sets do we need to keep that innovation going with this? Marinized electronics, motors, a lot of EMI and EMC, data links, comms, miniaturized circuit design, embedded systems, and of course the AI and the ML as part of the control systems here. And if you pause for a second, I'll give you a video here. Got to stop it for a second here. Hold on a minute. My fingers don't move fast enough. Okay, and I need to do sharing again. Sorry. I'll get better at this as we go.
So what's interesting about this product is a lot of the innovation that is being expressed here, the fact that it's unmanned, the fact that we're driving artificial intelligence and machine learning into it, is driven by advances in the threat environment. So our adversaries in the world have gotten mine technology that are no longer just kind of that World War II, the floating bomb in the ocean. The mines have gotten smart themselves, and that's why we need an unmanned platform to go into those extremely dangerous, lethal environments. And that is where the Red Queen comes in. The adversary made an advance, they became more lethal, and Textron had to respond by making something that could operate in that environment without putting the soldier or sailor at risk.
Okay, so I'll go ahead with the video. It's about the length of a tugboat, and it's deployed from some of the littoral combat ships. Okay. Okay, let me switch again. Okay, and go back. So the next thing we want to is show the video. The next thing is a ground vehicle. This is called the Ripsaw M5. This is a Hal & Hal product. It's being considered for a variety of U.S. Army and Marine Corps programs. It has electric motors in it. And why is that an innovation? It's quiet. It can sit in the woods. It can sit there and sit and be completely running its sensor suite quietly and look for the enemy. It can deploy a tethered UAV and a ground vehicle also if it wants to go into a building, a small ground vehicle. In some of the models, it's got a 30 millimeter cannon, the same gun that is used on the A-10s, fires at the same rate of fire. Cameras all over the place on this thing and LiDAR on it as well, doing avoidance, not running over soldiers nearby, being able to just know its environment. The skill sets that make the things that make this possible are knowledge of C2, ruggedized electronics, video processing, data analysis network. All of that stuff is important because you've got to have this connected. Some of the other skills really needed are power conversion, motors, batteries, battery management systems, AI and ML, like we talked about. They can take 360 views with video cameras on this system and knit them together so you get a full awareness. An operator could wear a helmet that would let him basically turn his head around and see all views from if he was inside the vehicle, and tons of sensor integration. So it's a really, really great platform, and you'll see in a minute how fast it is and versatile it is. Okay, let me pull that video up. Some of our folks were riding this one around in one of our parking lots, and with a hand controller from like a game controller and making it spin and do donuts in the parking lot at one point earlier this week. We had 4 of them here so that the company could come see it, everybody that worked here, and quite an impressive vehicle and bigger than you would think. Okay. The next thing I want to show, and I'm sorry that this is a little bit jumpy, is a Hal & Hal overview of some of the other vehicles that they make. I love that it passes the snowmobile. This is called Ripsaw, and a lot of the technology in Ripsaw is in M5. This is a manned vehicle. This is a vehicle that can be used in firefighting on the commercial side. And the next one, this is a firefighting robot that's been bought by several fire departments in the United States. It's already seen action inside a building where they were afraid of a collapse. And this is called the SMET, which is a smaller unmanned vehicle. That was a fast slide, but the vehicles are fast too. Okay. So innovation in unmanned air systems. So I'm going to talk for a few minutes about the evolution of two of our air systems. One is the Aerosonde fixed wing, and the other is Shadow. They're both ISR birds. They're unmanned vehicles in the group 2 to 3 range of UAVs. The Aerosonde is a fee-for-service business that we have, in which we take sensors, a variety of sensors that we can switch out inside this bird, and we go any place in the world, launched from shipboard, caught in a net off a launcher, and caught in a net off a shipboard or off the ground. And we're paid to provide sensor time any place in the world with this. And it's been a hugely growing business. That's been around for a good 12 years or so, 15 years. It has about nearly 600,000 operational hours in this group of vehicles. Shadow, which has 1.3 operational hours in combat, has been the tactical UAS for the Army for the last 20 years. There have been multiple instantiations of it. As you can see, that it gets launched off a launcher and lands on an airfield with a wire that catches it like you would on an aircraft carrier. So innovation with these. The Army said, we love Shadow, it's done tremendous things, but I need something that I don't need a runway with. So we've been able to take the Aerosonde, make it larger, make it much more capable of handling a wide variety of payloads, and adding 4 electric motors and making it a VTOL aircraft for takeoff and landing. It has a very small footprint for that. It takes off that way and then transitions to a gas engine for level flight. It's very fast. It has all the capabilities that the original Aerosonde has and more, and an expanded payload bay and a couple different kinds of payloads and options. We've also expanded the ability to have that payload controlled from small assets, small computers that a soldier could carry to take payload control of that. A lot of skill sets needed for this. This is an area where we've been constantly innovating and adding to. We've changed all kinds of different equipment in the Shadow over time, changing the antennas, changing its ability to withstand a GPS-denied environment, changing its ability to handle bad weather. And this is a constant thing that we've been making improvements to over time. Let me give you a video of Aerosonde, the quadcopter version of Aerosonde.
If anybody's been paying attention to the news, obviously with the conflict in Ukraine, these type of drone systems are becoming much more prevalent on the battlefield. And that is another expression of that Red Queen analogy. As the weapon systems get more lethal, we want to, as a country, as a defense organization, we want to field more and more unmanned systems to expose less of our soldiers, airmen, and sailors to direct fire. So that's where the enemy, our adversary, has advanced, and in response to that, we're trying to run ahead of them and stay ahead by inventing new technologies to stay one step ahead.
The next area that I want to show you is an area that I've been involved with for 14 years, eventually becoming the chief engineer for this group. It's called Unmanned Control and Battlefield Connectivity. So 2 products started about the same time, the OSRVT and the Universal Ground Control Station and its predecessors. The OSRVT is a piece of equipment that involves using a radio and a display device in order for a soldier that's dismounted to get situational awareness of his area. And what it lets him do is talk to unmanned and manned assets that have cameras or other sensors, and to bring that sensor data down to him on the ground, so that you can see what the birds above can see right on the ground. So if you're about to enter a village, or you want to see what's behind a hill, you can have that bird that's above you go give you that right there, and be able to communicate back to the controllers of that bird to go move that bird, or in some cases with some of the assets, to point the sensors where the soldier wants them pointed. In some cases directly by the soldier on the ground. It's been extremely successful product. We have anywhere from 3,000 to 4,000 of them deployed at any one time, and it's had multiple different form factors, starting with boxes that would sit on a table that you would need to put under a tent, to a ruggedized laptop, to a ruggedized tablet, to the device you see on the right side called Spot, which is a really small thing the size of a large cell phone that pops down. The soldier can wear on his chest, and he can carry the radio and basically get the same situational awareness he would have gotten with those bigger, heavier devices. And that gets fielded starting this year with the U.S. Army. The other product that I was a project engineer on was the Universal Ground Control Station. So this was an idea that the Army could fly 3 of their aircraft with the same control station. So first one would be the Shadow, which is the aircraft we make that I talked about before, General Atomics Gray Eagle, and Northrop Grumman's Hunter aircraft. Shadow, with this ground station and with its predecessors, like I said, has 1,000,003 hours in combat, and it's been used as a workhorse for tactical awareness. The ground station, in addition to having an operator who can control payloads, who can control where this aircraft flies, who can put mission plans in and fly them in a point-and-click way. It's not like a stick and rudder control that you might see on some movies of unmanned aircraft. We basically lay out paths, and they fly those paths, and we can make changes on the fly with that. The UGCS has also had a lot of computing capability, now dated at this point, so that it served as a data center, and it could disseminate payload products to all the users that were out there in the field. This could be big users or smaller users. It also had connections to Blue Force Tracker and Link 16. The innovation that we're going through right now is that we've taken the software that we used in that station and developed new software that is scalable, expeditionary, and portable. It could go into boxes that you could put in a tent or into an operations center. It can get put in the cockpit of an aircraft, a helicopter, or a jet. It could be on a dismounted soldier. And we're also working toward having connectivity between that command and control with the TAC environment that the Army uses all over the place. So that's a product I've been involved with for the last 15 years of my career, and I'm very proud of the work we've done on that. There's a Shadow video I'll show you in the ground station. You'll see some shots of the ground station with that. Two operators in the Shadow version. In the Gray Eagle version, there are 3 operators. It's a larger station. And that's the latest version, the Shadow Bird landing. There are all kinds of skill sets needed in the control and battlefield connectivity area. Collaborative behavior, cyber is a huge part of the work we do with this system, and to protect it and to keep it from being listened to. Network, AI and ML, data science and visualization for the payload products that come back, encryption, and virtual reality from a training perspective. Obviously, there's hard EE needs there, comms, radios, data links. EOIR payloads, displaying data, displaying video, processing that video, circuit, power design, embedded design are all things that we need with that. Okay, Matt.
All right, so this pretty picture that everybody's looking at is at its source about almost a 1 terabyte image, a composite image from a satellite. And what we're looking at is a mountain range that is displayed in false color imagery. And this is a product that Textron Systems Geospatial Intelligence Group works with every day. And it's a dedicated team of software engineers that basically write software that allows data analysts and imagery analysts to look at products from satellites or from manned and unmanned aircraft and really begin to look to not only look at the data, but be able to draw conclusions from it. For example, here, the red, I'm pretty sure, is snowpack. So this is actually taken from, I'm pretty sure it's firefighting efforts in the West. There's obviously a lot of military applications to this kind of data, and we're constantly in that kind of red queen's race with both our friends in NASA and the National Reconnaissance Office, 2 agencies that put up a lot of the satellites. So they're constantly evolving their camera technology and their sensing technology. And our adversaries are constantly coming up with new ways to disguise and defeat these, sensing platforms, their sensors on them. So at Textron, we're constantly innovating how our software can look at and analyze and apply artificial intelligence to analyzing these very, very large data sets to be able to draw conclusions and provide to our users not just the data, but the intelligence from the data, the actionable conclusions they can draw. So this image is one aspect of that red queen's race. Next slide. So this image is of an F-35, specifically an F-35A. So this is a U.S. jet, 5th generation fighter that is very capable in the electronic warfare domain. It's a product of Lockheed Martin, and we team with them to provide a lot of simulation and training and stimulation products for this aircraft. Now, what do I mean by stimulation? We have a product at Textron Systems that fights, it emulates a very large scale battle. So we provide a synthetic war game, and then we feed into the jet all of the data that it needs to think that it's being in the air. So we trick it so it thinks that it's flying. We emulate the enemy and all of its radar signatures, and then we feed that radar RF energy directly into the receiver units on the jet. So from the jet's brain perspective, it doesn't know, it can't tell the difference of whether it's on the ground or actually in the air getting fired at. And as Lockheed Martin advances their aircraft, they're constantly updating it because obviously they're coming up against adversaries in the world that aren't standing still either. That dynamic plays out so that we're constantly at Textron Systems running to keep up with the aircraft as the aircraft itself advances. So we're constantly pushing the envelope of our digital signal processing and our software to be able to keep up with the modern threats and the aircraft itself. Next slide. So speaking of modern threats, if you guys have been tuning into the coverage of the Ukraine conflict, you may have seen these in the background. And they've gotten a lot of press lately because of their lethality. This is a S-300 surface-to-air missile system. The country of operation is Russia. On the left-hand side, you can see those vertical tubes. They are the missiles themselves in their launcher canisters. And on the right is a phased array radar, that big plate that is kind of at a 45-degree angle or so up there. That's a radar that the truck on the right uses to search for aircraft in the sky, namely things like the F-35 we saw in the slide prior, and then shoot them down with the missiles from the vehicle on the left. Our adversaries are constantly advancing their technology. That radar on the right has a range of classified range, but it's in excess of 100 miles, and it is phased array. It can pick out many multiple targets in the sky at a time and actually feed targeting data for those missiles for multiple launch vehicles at the same time. Those launch missiles can reach speeds in excess of Mach 5. So you can imagine the reaction time for an incoming missile that's going 5 times the speed of sound is not very long. So as the threats evolve in the world, Lockheed Martin evolves, and then we evolve with it. Next slide. This is an aircraft, if you've seen Top Gun Maverick, this aircraft was actually in Top Gun Maverick, but it was CGI because this is a Su-57 Felon. This is another aircraft out of the Russian state, and it is contemporary of the F-35 or the F-22 Raptor. It is a very capable 5th generation fighter, has some stealth characteristics, and again, this is one of the things that we at Electronic Systems are asked to emulate and asked to put into our synthetic war so that the F-35 can train against these type of platforms without actually needing to encounter one in the real world. We can't go and fly against these in the real world, and hopefully we never do. But Lockheed Martin and the U.S. Air Force, U.S. Navy, they need to be ready for that conflict when it comes. The only way that they can get ready for these threats that you can't go and train against is to train against them in a simulated, conflict. And that's part of what our software teams, our FPGA designers, our electrical engineers, our systems engineers, all of those teammates of mine work to generate the synthetic environments that we can emulate that pretty badass plane and then allow it to fight safely against our aircraft, United States aircraft, so that we're ready if conflict ever did, God forbid, break out with Russia. Next slide. This picture is just kind of a snapshot or a microcosm of all the different kinds of radar and RF signals that are in the environment. So we can see that we have everything from friendly radars, friendly data links, to their adversary kind of mirrors. We've got threat radars. We've got background signals that are not of really that much interest to an F-35, but show up in the electromagnetic environment. So cell phone signals, the airport radar, things that aren't threats, but they're still kind of confusing to the listening devices on our friendly jets. And so we need to model all of those. And that's another aspect of the Red Queen's race that we need to take into account, is not necessarily our adversaries or our friends, but kind of third-party, neutral actors. Where is the rest of the world going from a communications technology perspective? All of these things kind of impinge on how we stay current and we stay relevant. And it's pretty much universal to all defense, industry companies. Next slide. So interestingly, in the old days, these systems didn't need to be all that sensitive. As a part of that aspect of that constant arms race that's going on, Textron Systems, we make electronic warfare simulators today that have requirements to deliver accuracies as low as 50 picoseconds. So a picosecond is 1 trillionth of a second. And in 50 picoseconds, photons travel about 0.6 inches. That's about the length of a honeybee. So you can imagine the level of detail, the difficulties that we encounter with trying to hit accuracies of 50 picoseconds. And all of that technology, all of that development, all of that blood, sweat, and tears that we put into it is driven by advances in the world external to ourselves. So we try to stay ahead of it, but it's always at the core being driven by the other guy improves, and then we try to improve past him. So that dynamic plays itself out, and it's driven us to kind of this extreme. And we're really pushing up against some real physical limits, some limits of where physics really starts to take over, relativity starts to take over, speed of light starts to get important as you start doing your calculations. So we're really up against a lot of physical limits, but that's where that Red Queen's race has really pushed us. Next slide.
So I think we're at a point where we should be able to take questions.
Yep.
Hi, Bill and Matthew. Nancy Austin here. I see a couple of questions that have popped up over here in the Q&A section. So if you haven't seen that, I'll help you out and make sure we ask those questions. One person asked, how do soft skills play into being an effective innovator?
So I would say that the soft skills are of paramount importance once you get past the stage of being an individual contributor, because no matter what industry you're in, no one single person has all the answers. And the soft skills act as the glue that allows you to bind together the diverse skill set that you need. I'm a software guy by trade. I'm not an electrical engineer, but when I design a total system, the soft skills that me and my leaders bring to the table allow us to bring together diverse thought and diverse people and diverse skill sets and meld them into a team. And you're not really, there's a myth that innovation is some guy sitting alone in a lab somewhere and a light bulb goes off over his head and eureka, he's invented something or she's invented something. That is not true anymore, especially not today. It might have been way back in the day, but today it really takes a team. And that's where, a lot of lip service gets paid to diversity and stuff. But at the end of the day, diversity of thought and diversity of experiences brought together by those soft skills and being able to bring the best out of other people is really what leads to innovation.
Yeah, I totally agree. To think about this, if you had a room of 10 engineers in there, the guy that's the loudest isn't necessarily the smartest. You need to get your introverted engineers to tell you what they're thinking. You need to create an environment where they feel comfortable and they can share that information without threat or without being uncomfortable. And you need to just work that and know your people and get them to work together well. And I think it's between what Matt said and that is what you need.
I think we talk a lot about interdisciplinary teams, and we've done many issues of the Bridge, our Bridge magazine, and a lot of the sessions we do and work with different industry experts like yourselves and other groups. We talk a lot about that. There's nothing, you might have a degree in one particular aspect of technology, but every team is going to be an interdisciplinary team, and electrical engineering in particular, it's a part of everything. That happens because everything has a circuit. And I think Vince Cerf said it really well today when he spoke to us earlier. And he really he talked about how software is everything. Right? You can have the most sophisticated things, but it all needs software. So I think it's a really good point. Soft skills often get brushed aside as something, that sounds nice, something to have, or maybe it's an industry term, but I think it's because of the nature of team science and how things really are developed today. I mean, this stuff is fascinating. I mean, it's super interesting. I saw Top Gun the other night, so I was like, wow, it's amazing that these things exist. For those of us who don't work in it every day, it's just amazing. We go, it's just crazy what you guys do and what y'all get to do. And it's, thank God you're doing it, right? Thank God you're out there protecting us. Someone else asked, about how do you stay, advice for staying technically relevant and keeping up to date on all the innovation happening in the defense industry? And how do we keep our skill sets from getting stale or outdated?
Oh, that's hard. As one who is about 3 weeks from retirement, that is a really good question. You can't keep up with everything. You have to trust the people that are below you, that they're doing that. Mm-hmm. And you have to ingrain in them that they've got to trust the people even younger. Mm-hmm. The best ideas in my group come from most of the folks that are under 30. That seems to be, and the rest of us are there to kind of throw some English on that to make it happen. That's my observation with teams. Mm-hmm. You can't know everything, but you can know enough to know when it's important and to pull people together.
Yeah, it's a great question. I don't want to sound trite, but it is kind of a truism. If you find yourself being less curious, you will fall behind. And this is, yep. Your question gets at kind of almost the Red Queen's race again. Mm-hmm. You have to keep running. I learned things from industry magazines, from staying kind of attuned to things going on in the industry, learning from new folks that are just getting out of school that have had touched on things that I've never heard of before, and they bring great ideas to the table. Mm-hmm. All of those things start at a root core of staying curious. If you stay curious and you keep learning it. Anybody that thinks that they're going to graduate from whatever program they're in today and stop learning, just throw that away. Just that idea is not really that great an idea. You got to keep learning to stay relevant.
Well, I would say very much so. Like HKN, at a company particularly, it's a group of people that are very like-minded, and maybe most enter when they're in university, but throughout their career, it's really important to stay connected to other people who are doing other very interesting things, maybe close to what you're doing, or maybe not even close to what you're doing in the industry. And then, of course, IEEE. We talk a lot about our technical societies and what's happening in those technical societies and technical conferences. And I would say to everyone, you probably need to belong to the technical society closest to your areas of interest or what you're working in if you want to stay current and network with the most current experts in these fields. So we love having you all with us because, again, I learned stuff, and I'm not an engineer, full disclosure. I get to play one at work, but I'm not an engineer. And I learned the most fascinating things from all the sessions we put together. And so I really appreciate that. Someone asked, was Beechcraft once part of Raytheon? I don't know if that's
I don't remember. I'll be honest.
You don't remember? I don't know if that's really
yeah.
And we do have some international students on the call, and I know you're working in the defense industry, so that's particularly if you're not a U.S. citizen, that's an issue. But any advice for international students who are
even if the technology is in defense, it doesn't mean it doesn't have applications non-defense. Mm-hmm. Applications for civil, applications for police, applications for just protecting people in general. The situational awareness stuff that I've worked with is fantastic for first responders, for firefighters, for people putting out forest fires. That stuff saves lives. If you know,
yeah, that
what
was
the
really
dangers are.
fascinating.
So
that
there
was
are opportunities, and I would certainly, with regard to Textron, we have commercial businesses too, and I would look at the open positions that are related, because so certainly Textron Aviation, Cessna Beechcraft, Hawker, they all have needs for very similar skill sets and very similar products. You know, we're looking at a white paper the other day, writing a white paper about how to apply what we're doing in defense towards allowing drones to fly near airports or not. You know, where you have that kind of a thing going on. And one of the things that I remember when I was on a trip, and I was at Textron Aviation, and they had an EMI lab in which they were doing testing. And one of the guys that was there, I think he's long since retired by now, said, well, don't tell everybody, but I'm going to tell you that you're going to hear on the news next week that you can use your cell phone on a plane. And he had been doing all the testing to verify that there really wasn't an interference problem with modern cell phones. So, you know, all that the technology that we use is applied across both civilian and military applications. And some stuff absolutely starts in the civilian side. The military is learning that more and more, how to get a hold of something that I can use home to play a game, to do something that'll make me more efficient, make the work get done better.
Well, the internet was a defense project, right? It was the APRNet, and it was really done by the defense industry, or the government in the defense industry.
Yeah.
So, you know, again, we look at these applications across technology, and you all, it's great that you're all here with us, and you're also over in our expo center. So you are recruiting, currently recruiting for different positions. So I know I want to encourage everyone to jump over there and look at to see the open positions that you have and what you're recruiting for. So what are the top things you're looking for, the top positions you're trying to fill over at Textron Bell, and you know, who are you looking for right now? Where are the jobs?
Double E's, cyber, software. They're the hardest positions to fill.
Yeah, exactly. We have open positions in just about every engineering discipline right at the moment, from FPGA developers to traditional circuit card design to software user interface, embedded software, you name it, we've got it. Hop on over, take a look at our open recs.
Yeah, I mean, you guys have a massive company. Really, it's just amazing. The more I've worked with you and gotten to know you, because you're also everywhere, right? You're all over the place. So it's not like you're located in one area, and so you're only recruiting you're recruiting all over the country, maybe all over the world, right?
Yep. And we move talent and information and skills between companies a lot. We've gotten much better at that in the last 5 years.
Well, that's great to know, because then there's a lot of
people, moving people, giving them opportunities for their career to go to different parts of the company.
Yeah, well, so that's great to know. And again, someone 3 weeks from retirement. Wow, Bill, we're all a little bit envious of you.
39 years here. So.
You'll get the summer off, and then some, right?
Yeah.
But that's great. I mean, I think, you know, there's a lot. You've given us so much information today. Thanks for the great videos and the amazing conversation. I mean, like, you're right. Anybody who saw Maverick Top Gun said, wow, that's the most amazing thing. I was just great that at Tom Cruise's age, he can still fly a fighter jet. I mean, that's just, I'm like, I don't know. Sometimes I don't want to get in the car because I'm thinking, I don't know if I can handle that. But that was really, really quite amazing. So this technology is really cool. The things that you're doing is so interesting, and I really thank you so much for being with us and sharing your things about your company, all the innovative things you're doing, and how this innovation works. And certainly, really want to encourage people to go and look at your open jobs and go over and look at the opportunities available over at Textron Bell Systems. And you'll be here tomorrow. We have our power hours. And the power hours, what are you guys going to be talking about in your power hours? You've got some really great discussions planned.
I'm actually not going to be there tomorrow, so sorry to say.
Matthew, do you have the list of what's happening?
Honestly, I'm not sure. We have a different team handling that tomorrow.
Oh,
so
sorry.
You'll get a whole different slew of ideas and thoughts from those folks.
Yeah, but pass questions on. I mean, we're certainly willing to look and send resumes in.
Yeah, those are the power hours are designed to be these more in-depth technical conversations where everyone can come up on stage with us. You can, in the sessions, you can talk to lots of experts. And I know you do have a lot of people going to be there. So that's going to be tomorrow afternoon. So we hope people come back and join us for power hours and really have some great conversations with our friends here from Textron Bell and all their related companies, because I think there's a lot to learn and a lot of great conversation we can have. We all improve when we have this kind of dialogue and we learn from each other. So thanks for joining us. We do have one more session this afternoon, so don't leave just yet. We have a session coming up from ANSYS, which is Electrification for a More Sustainable World. It's with Charlotte Blair, who's the Electronic Simulation Tools Manager at ANSYS. You talked a lot about simulation, so we're going to go over there and talk about that now. That's coming up just at 5 o'clock. And again, thanks so much, Matthew. Thanks so much, Bill. Congratulations on your retirement.
Thank you.
Thanks for being here with us. We really appreciate all that Textron does to support EDICAP-NU and IEEE, and we're glad that you were here with us today.
Thank you.
Take care.